This is basically a summary of the work that we've been doing since the beginning, middle of May, I suppose. All right, first part of May, when I was awarded this contract, I spent a few days in New York around Ground Zero for the purpose of the film crew, the production company, wanting to get me filmed and walking around that whole facility. And so that was done. That was pretty interesting. And so I have two students working with me, Fong, who is a structural PhD student that works with me, and Zili Kwan, who is also one of the PhD students that's working with me. So the history of the study that we're doing is WTC1 and WTC2, the twin towers that you probably have known about, were both struck by a commercial jet airline on September 11, 2001. That was a day that we all can remember. The buildings not struck by the plane suffered damage. Hours later, WTC 4, 5, and 6 were damaged. WTC 7 collapsed. WTC 7 is the one that I'm going to be talking about. It's a 47-story building. It was not hit by a plane, and yet it came down. So that's what we're going to be talking about today. So let me just kind of introduce you to what this thing is. The World Trade Center complex, the project was developed by the Port Authority of New York and New Jersey, combination. It's called the Port Authority. And it's a bi-state public agency. The original occupancy of the towers was dominated by governmental agencies, including substantial occupancy by the Port Authority itself. That's the WTC1 and WTC2 I'm talking about. In 2001, the predominant occupancy of these towers was commercial tenants, including a number of prominent financial and insurance service firms. This is what it looks like. If you've ever been to New York, then I don't need to tell you this, but this is WTC1. It's 1,368 feet tall from the roof to the bottom, and there's a 360-foot tower on top of that. WTC2 is the other tower. This is 4, 5, 6, and 7. And then there's a number 3 hidden behind here in this area right here. WTC1 and WTC2 after the impact. At 8:45 a.m., Flight 11 struck WTC1. That building collapsed at 10:28 a.m. At 9:03 a.m., Flight 175 struck WTC2, and the building collapsed at 10:03. So about an hour is all it lapsed between the time of impact to the time it came down. It kind of gives you an idea of how quickly those things were brought down. The WTC towers 1 and 2 are the primary complex of the World Trade Center complex. Each of those towers is 110 stories from the plaza level up and 7 levels below ground. So that's the way they were put together. WTC1, the North Tower, had a roof of 1,368 feet. It also supported 360-foot tall television and radio transmissions above it. That's what that look was when I was showing you just a moment ago. So this is that tower, 360 feet above it. At the time it went up, these were considered tall buildings. WTC2, the South Tower, had a roof of 1,362 feet. Each building had nearly an acre of floor space. So each floor had about 44,000 square feet. You can imagine that, 110 stories. So that's a lot of space. The floor surface area, the overall dimensions was approximately 87 feet by 137 feet. And in the center of that building, it housed 3 exit stairways, 99 elevators, and 16 escalators to give it transportability up and down within those buildings. This is the complex. This is what we're studying over here. This is a very deep foundation area, and on that deep foundation is WTC 1, 2, 3, and 6. 4 and 5 are on shallow foundations. The WTC 7 is actually was built on a substation, its own foundation, which is a big area of concern to me. WTC 4, 5, and 6 are basically 8- and 9-story buildings. They're steel framed, and they were located on the north and east side of it, and they were built in 1970. They were the first to go up. Because, and they had underground parking and all that kinds of stuff going on here. Because of the close proximity to WTC 1 and 2, all 3 buildings were subjected to a lot of debris damage. However, they did not come down. So imagine that 4, 5, and 6 was struck by the stuff coming off of 1 and 2, did a huge amount of damage to those buildings. Also, they caught on fire, but they did not collapse. There was no progressive collapse of those buildings. So what is this WTC 7 thing? So it's a 47-story skyscraper. It was built in 1984, and at the time, it was the highest building in 33 states that went up. It didn't last very long, though. After that, many other buildings went up with a lot more stories. At 5:20 p.m. in the afternoon, it came down. And that is the subject of the controversy we're in. So I'm going to tell you right now, what I'm studying is a very controversial study. It has to, probably each one of you sitting in this room has an opinion about what I'm going to talk about. And yet, so who's funding this? The people that are funding it are 2,355 registered architects and engineers in this country who've said the NICE report needs to be re-examined. And so they're funding it out of their own pocket. It's a non-for-profit corporation. So they have taken it upon themselves to see, they believe that the people deserve an answer, and that answer should be scientifically done and defended. So I'm going to share with you how I'm trying to approach that. This building was not hit by an airplane. It suffered minimal damage compared to other buildings much closer to it, and yet it failed. It came down. The NICE report claims that the building collapsed because of fire on the 13th floor, and the fire resulted in a significant move of the support for column 79. So from this point on, if you can see that little thing, I'm going to try to use it, okay? And if it doesn't work, holler. There's some facts about Building 7 that we need to talk about. If fire caused Building 7, and when I say Building 7, I'm talking about WTC 7. If fire caused Building 7 to collapse, it would be the first ever induced collapse of a steel frame building high-rise building due to fire. So that raises some question right away. Building 7's collapse was not in the 9/11 Commission report. According to a poll in 2006, 43% of the Americans did not even know about Building 7. It took the federal government 7 years to conduct an investigation and issue a report about this building. 2,355 architects and engineers have signed a petition calling for a new investigation into the destruction of this building and the towers. So I'm only doing the 7 right now. Numerous witnesses say that the possibility of demolishing Building 7 was widely discussed by emergency personnel at the scene and advocated by the building owner. Building 7 housed several intelligence and law enforcement agencies and the New York City Office of Emergency Management, Emergency Operations Center, and more commonly known as the Gulhenny's Bunker. Here's the layout. WTC 1, WTC 2, and here's WTC 7, sitting over here, 47 stories up. This is the layout at the ground level. Now, I've told you it's supported on a substation. What you're looking at here are the caissons. And the green represented existing caissons. The blue were new caissons put in to support this building. So they built this on top of another building, basically. What I don't know, and I would like to, and I've asked for, and I'll share with you a little bit about how I'm going to approach this thing. I've asked for everything I can find about the framing of that substation, and all of the caissons, soil borings, everything I can get my hands on. I don't have any of it yet. But there's reasons why I want to see all that. This is the layout, elevation view of what this building looks like. And so here's the Con Ed substation that is built on. A shipping ramp over here to our right, Con Ed substation. And you can see that's not a uniform system. There is a stiffener, which is basically a truss system, like the belt around your pants to hold you up. This is what's called a belt truss at between floor 7 and 5, or 5 and 7. Also between 22 and 24 is a stiffened system around the building. Okay? The plan view looks like, hang on a second. The plan view looks like what I'm seeing down here. A represents north elevation, B south, C and D east and west. This is a framing system that looks like between the 7th floor, the 6th floor, the 5th floor of what the building and its bracing might look like structurally in just one location, one glimpse of what might be there. Looking at from the side, this is kind of what the building looks like. It's got what do they call those on top? Anyway, there's a small building system up there. A little bit of background. This is the reporting record of the failure. At the end of 2008, the NIST report published the final official report on the destruction of this third skyscraper that was totally destroyed. Discarding any earlier official hypothesis and based on no physical evidence, as no metallography could be carried out because the steel was hauled away. There was no material left to be able to evaluate this stuff. The Institute claimed that the ordinary office fires resulted in an extraordinary event and the skyscraper's total symmetric destruction, which progressed at complete free fall acceleration for over 2 seconds or a span of about 8 floors. So that's what came out of this. This is the failure. If you imagine these white lines right here are vertical, and you can see as you look at it that the structure is basically coming down as a straight line. Almost, it's amazing how straight it's dropping. This is an example of what happened after WTC 1 came down and there's 7 standing. This was earlier in the morning. Remember, this came down at 5:20 in the afternoon. So what happened? WTC 7 fell on an average of 7 floors per second. That's 47 floors in a 6.5 second period. 1 second after the onset of the collapse, the speed of descent was almost 10 meters per second. After 2 seconds, it was 20 meters per second. At the end, about 60 meters per second or 200 kilometers per hour. So a physicist and others have looked at this, and according to the analysis of Frank Legate, who has a PhD, the rate of descent of WTC 7 closely matches the rate of gravitational freefall, which combined with the uniformity of the descent throughout the breadth and length of that building. So it kind of indicates there was no resistance to the drop. So if you just buy that data alone, it has to put in questions a lot of things about it. So our objective is the following: to rule out any impossible scenarios that could have collapsed the building and test the official NIST report. So how do I go about doing that? So I'm going to share with you some things that are not on these slides, but how and what I'm considering. I have to be very, very careful that I do not want to prejudge or predetermine anything. I'm going to let science drive the solution. So how do I do that? I don't want to know. I've learned more in preparing this presentation than I knew because I didn't want to know anything. How can I possibly keep non-prejudicial view scientifically if I know too much? So I didn't want to know anything. But I've prepared for this to share some things with you, and now I know too much. So I'm going to try to do the best I can to purge it out of my mind. So what I'm doing now is we have some approaches that I've taken, and so we're using 2 PhD students, 2 computer programs, One is SAP 2000, the other is Abacus. And we're modeling both at 2 floors at a time on this building to try to get an assessment of how they perform with respect to the other floors. And because they're each creating the model of the same floor, we're comparing the results of 2 different programs with two models to make sure that the models are true and accurate. So I can base information on the correct information and not something that we might think is okay. So I'm having quality control built in at every step of the way that I can. We're putting everything on AutoCAD. And so through the AutoCAD process, we are going to create our models, which are finite element models, the SAP models, and the Abacus models from those AutoCAD files. And I'll go through that with you in a moment. So I need to be careful because I'm going to run out of time. Steel is a fire-resistant material, and in tests conducted by Chorus Construction in several countries, the fire endurance of steel frame parking garages was examined by feeding fire with hydrocarbon fuel, and in so doing, steel beams and pillars heated to a maximum of 300 degrees Celsius, and the breaking of steel was not even close. In other fire endurance tests, they modeled conditions of real buildings. Unprotected steel was subjected to temperatures of 1100 degrees, but there was no collapse. Similarly, fire experiments conducted by the National Institute of Standards and Technology, NIST, the people that wrote this report, tested the pancake collapse theory by modeling fire exposure of WTC floor assemblies. And if you ever read anything about WTC 1 and 2, they said it was a collapsing theory. They dropped. There was no collapse, although they ignored the results in its final report and acknowledged that the results established that this type of assembly was capable of sustaining large gravity loads without collapsing for a substantial period of time. So there's even questions about their reports on those two. So in the Windsor building in Madrid, almost 24 hours of intensive fire did not collapse the building. Moreover, the fires in WTC 7 were small compared to fires in Windsor, and the situation there, that by some accounts, believe the fires didn't last more than 20 minutes. So the latest case in the overall engulfing fire in the NASA Tower in 2006, fires have never collapsed a single steel framed high-rise to the ground. Never. So now, that's where we are. Fires in WTC 7. In December 2007, it was acknowledged in the advisory committee meeting of the NIST that the fires in WTC 7 were ordinary office fires and burned out in a given location in about 20 minutes. In such a short time, the temperature of fire-protected steel members would have maxed out below 20 degrees Celsius, or about 400 degrees Fahrenheit, and such temperatures would have no effect on the construction steel. That being said, that building had fire protection, and it also had sprinklers. Now, there's some controversy about the sprinkler system. Not everybody says that they were used because all the water had been used on WTC 1 and 2. I don't know the answer to those questions. There's just a lot of questions. I also don't know any of the materials. There's a lot of things we don't know. I have requested structural calcs. I've requested structural design drawings. I've requested anything and everything I can get my hands on, and I'm still waiting, and information is coming. I may not get everything I need. Tower 7 was one of 7 buildings in the World Trade Center complex in New York, and that skyscraper was 610 feet tall and just 350 feet away from the Twin Towers. As well as housing offices of leading financial companies, Tower 7 also had some unusual tenants: the Secret Service, the CIA, the Department of Defense, the Office of Emergency Management, which would coordinate any response to a disaster or terrorist attack. So you might say, Hulsey's got definitely is non-prejudiced, Well, I'm just documenting things I've read over the last day or so. So NIST determined that there were fires on floors 6 through 13, except for floor 10, and also on floors 19, 21, 22, 29, and 30. So there were some fires. This is an example of a fire on the north side, fire on the east side, up and close and personal. So Column 79 is the one they said gave way and caused this structural failure to occur on floor 13. You're looking at floor 13. This is a 41,574 square foot floor, approximately. Column 79 is over here. The fire started here that they looked at. Basically, they said that fire caused expansion contraction of enough movement that the bearings that this girder sat on that supported that column moved off the bearing system and it caused the column to drop. So we've actually tried to model that. We're in a point right now where we're modeling that. We have not completed our final results. We have preliminary findings, but I'll share with you some of those findings here shortly. So 47 floors have framing plans, structural detailings, and here's what we had to deal with to create our AutoCAD drawings. It's not clean. It's a pretty big mess, quite frankly. So, and it's a JPEG, and so you have to blow it up, and when you blow it up, then you lose a lot. I mean, so trying to make this work. So we created AutoCAD floors 12 and 13. This is our AutoCAD drawing. I apologize for it not standing out there and looking really, really wonderful, and we've tried to do everything with the background to make it better than that. It looks great on my screen. It doesn't up there. I'm sorry. And this is a roof framing plan. But so SAP 2000 and Abacus is kind of what. Now I will try to share with you, those of you that are not engineers. SAP 2000 is what's called a finite element computer program. It's two-dimensional, three-dimensional. You can simulate a real structure in it, structurally. Abacus gives us the same kind of thing. We can basically simulate what's going on. I would say an approach, and I'm using this in the documentary, I'm saying basically we're creating a virtual building. We're creating a virtual building when we're going to simulate its behavior due to the conditions that we're going to give it. So if I have a virtual building that represents the real system, I ought to have some understanding of how it responds to conditions I give it. So that's the game I'm playing. So we're testing the modeling for composite and non-composite steel beam behavior. We tested those against hand solutions to make sure everything we're doing is correct, make sure our modeling system works. When I say composite and non-composite, I mean the slab is either connected to the steel beams or they're not. Non-composite means they're not connected and the concrete slab can slip with respect to the steel. When I say it's composite, they're locked in together, the concrete's been placed, there's what's called Nelson studs in it. It's actually welded to the top of the steel beams. The concrete is poured, everything becomes one. So if it moves, if the concrete moves, the beams move. Beams move, the concrete moves. We're looking at both of those. This is a typical AutoCAD, but also SAP 2000 model coming out of floor 12s and 13. We're looking at one floor. We're looking on top of it, basically. So that's the framing. This is looking on top plan view. That was kind of an isometric of it. And so here are all the girders that are in here and the beams and the framing system. And so all that kind of stuff to try to get a handle on the behavior. Looking at it from the side, 3D, kind of gives you an idea. I'm looking at how does floor 13 respond with respect to 12. Then I'm going to look at how does 10 respond with respect to 9, and so forth. So we're going to go all the way up, 47 stories, looking at floor to floor to floor to floor to start to see if there's changes, irregularities, things I need to worry about, things that might jump out and we might not know if I didn't do that. Then we are going to take it and put it together. But this is a deflection under self-weight, highly exaggerated, I might say. It isn't going to deflect that much. But it doesn't deflect very much. It's pretty stiff. But this is what it looks like if it was a lot. Floors 12 and 13 with what we call release joints. I'm basically loosening it up, letting it be more flexible than it might be, and trying to look at how it behaved under those conditions. Again, that's under gravity loading, deflection with release joints. This is taking 10 of the floors of the 47 stories and putting them together and kind of showing you what we have to deal with. It's not trivial. And then there's concrete on top of all that. So we are looking at the behavior of this system and seeing that if one column fails, what happens to the building. And so right now we're focusing on column 79 because that is the interest of the funding agency. It's also the interest of a lot of people in this country that column 79 is off center, yet this building came straight down. So, software modeling. I'm using SAP 2000 and Abacus to examine the accuracy of the WTC models. I'm looking at result comparisons. I'm checking each other. We're using Abacus to simulate the WTC7 collapse. That means we're going to subject it to fires, to simulate the fires that may have occurred, the documentation of where those fires may have been. We'll look at the heat transfer. Heat transfer means when the steel went under fire, it starts getting a little bit warm. And when it gets a little bit warm, things tend to expand. And when it begins to expand, it begins to influence things. And so we're going to look at what that does. We'll look at changing material properties with temperature, because as it heats up beyond a certain temperature, steel and the concrete do not behave the same way they would have if they hadn't gone into those high temperatures. So if that's the case, and right now everything we're doing, we're saying that the steel does not have any fire protection. It was supposed to be, by design, supposed to be, by inspection, to have a 2-hour fire protection on the steel. That means they would come in, they've sprayed it, and it would have insulation. It would have been insulated against a 2-hour fire. And they also was sprinkled. I don't have any inspection records yet, but we do know that there's documentation about it having fire protection. I'm assuming the worst right now, and if I can't make it do what everybody else said it did with the worst, then it didn't happen. You see? So that's the approach. I'm taking the worst condition, I'm going to look at the best condition. Right now I'm looking at the worst. We will try to see if that's a possibility. Due to that property change, there's a nonlinear response. In other words, it's not going to behave the same way it would have otherwise, and this piece of software will enable us to do it. The other thing about the Abacus is that if it won't do it, we can write an algorithm and add it to it and make it do it. So there's things that we can do. And we're going to look at structural stability. Did the column, because it moved off of the bearings, if it really did, then its length against buckling is way bigger than it would have been by design. Would that have occurred? We're going to check that. Okay? Anyway, so I looked at the stiffness of the floor 12-13 system, and I said, okay, I want to look at where's the centroid of that floor. And so we located the centroid, and now we're going to subject this floor 13 with respect to 12 to an axial load, a load in the plane of the floor, and see how much it moved. What I'm really looking for here, folks, is this. Did it move uniformly, or did it move and rotate? You see? I'm trying to find out, under a response, what is going to go on. I then took this and put a load that way and checked the same thing to see if there was a rotational system. Once we got done with all that, then I actually rotated it. I then said, okay, I'm going to rotate around that centroid and see what happens. Did it rotate uniformly, or was there some changes going on? So anyway, so we put 10,000 kips on here. We applied it to see what was going to happen. And that's kind of a three-dimensional picture, and that's using Abacus. There's the Y direction. Then we looked at each one of these points, each number. The numbers don't matter, but the points are, I'm looking at this relative to that, relative to these. How much did it move? I'm looking at, did it move as I would expect, or did it do something crazy? So what is really going on with this building? Then we looked at what we call rigid condition supports and non-resistant condition reports or connections, and we looked at the relative stiffness of one to the other, and it didn't really matter much. So it appears that slab is hugely impacting everything. Preliminary study, we're going to remove the column 79, heat 1/4 of the floor area 12 and 13, that's where NIST put it, apply 1,000 kip vertical load, test it, and we're going to look at its behavior. So there's the loading point where column 79 exists. Has everybody got a picture where column 79 is at? What is that? Why am I making that such a big issue? I'm making it because NIST said that's where it failed. So this is where the fire is. This is what it started looking like. This is vertically. So here's column 79. Here's the movement. And we can see that it's supposed to move about 6 inches. It only moved 2.9 and 1.6. Not enough to move it off the bearings. Preliminarily, that's what we've got so far. So frame connections have limited influence on global stiffness. Loading and heating of cotton will not result in large movements at column 79. So that's where we are. I apologize I had to run through it, but I wanted to get it done by 1:45, and we made it.
Great.
Okay.
Thank you very much.
Any questions? Yes, Ori.
When you heat steel substantially, does that change its plastic
It does.
properties?
It does. That's why I've got nonlinear properties in here. That's why I've got, I didn't put it in a slide, but I've got the change in properties with temperature. The remarkable thing of it is, though, even with all the tests that have been done, fire endurance tests of real structures, they haven't found it to cause a collapse, which I found to be interesting. I thought, I mean, I've been involved in a lot of fire tests, but not of a full-scale building before. Okay. Yes, you had a question.
You talked about the tenants were the CIA, the Secret Service, and Juliana's bunker, which was the emergency management.
Yeah.
Have you ever considered that maybe because of the kind of those locations could be considered a target, the tenants themselves would have installed some sort of blast protection, some sort of industrial added weight?
I've heard that. I have to really put away all of that stuff. You know, as a scientist right now, I can't afford to go there with any of it. I will say that I'm really quite worried about the substation. The substation, from a different point of view, it's not about what they might have had stored in there, you know, in terms of possible terrorism or anti-terrorism or any of that kind of stuff. But I understand there was fuel down there, a lot of it. And I'm going to try to pursue that. But if they truly did have a free fall condition, that means there was no support below where, and so what would have gone on, if that went away, then that would explain why the building dropped in a free fall condition. What is really quite interesting is why did it come down so straight? Yes?
What about modifications to the structure?
There were some modifications. I think it was floor 12. We are looking at that.
Intelligence agencies and stuff, you think all of it would be listed?
Well, I don't know the answer to that. I do know that we've got documented changes, but that was from the developer, the owner, and trying to get good information is a challenge. A lot of it's locked up in vaults because of previous lawsuits, and so the next thing I'm going to try to do is, because a lot of people prior to this study have tried to get things and they haven't been successful. But being a professor, I might be somewhat successful. They may not feel so threatened. Yeah, I don't know. The only thing I can do is try. So we'll see. Any other questions? Yes, Anne?
I'm not an engineer, we're going to preface that. But it seems to me when I look at this looks like those imploding buildings, you know, when they bring the building down, where it's all very uniform and it all comes into itself. So I wonder if you consider the what-if scenario of bringing down this building all by itself in that fashion, what you'd have to do and where you'd have to attach it and all the different steel beams to make it go down like that.
Well, that if I'm asked to do that, I will do that. But I'm going to try to avoid that, because that takes us right into that world that everybody says, oh, you know, everybody's got these theories. But let me just say this, I will preface this. This building is not symmetrical, meaning that it's not square, it's not rectangular, it's got two sides that go this way, so the back side is longer than the short side. The probability of it coming straight down is almost impossible. So then you have to ask yourself, why did it? And I haven't gone there. Yes?
You're talking about it not being symmetrical. I was noticing on the structural view, when you were noticing beams that traverse the floors, from my view, the left side of the building seemed to have, I believe, probably 20% more beams running through the floors.
There's irregularities everywhere, and of course it's not uniformly rectangular either. I mean, so why would it come straight down?
I was more wondering, is there a reason that one side of the building seems so much more had?
I don't know the answer to that question. Anno brings up a very interesting point. Is the first thing you have to ask yourself, you have to work really hard to bring a building straight down in a small space. There are engineers, structural engineers that do that for a living, and it doesn't happen accidentally. It's got to be designed to do that. So why did it happen? I'm going to let you answer that. Yes.
What sort of debris was the building hit with, and do we know what actually caused these fires in the structure?
Oh, I'm not sure about all that. I'm still looking at that. There wasn't much, Ori, and there wasn't much fire. Matter of fact, the fire department was there. They left and said it's not enough to worry about. And so that leaves you to another question. So they went back to their group and didn't go back. And then it came down. So. Yes?
Do you know the quality of the steel that was used to build the building?
I don't yet, but I will know. We are calculating that. If you look at the debris of the steel, you have to ask yourself some other questions. I have not ever seen a building come down, and I've investigated a lot, where the steel and the concrete were not broken as a piece. In other words, if you might have a piece of steel and a large clump of concrete attached to it. I didn't see that. Very little concrete was attached to the steel. A lot of it was pulverized. It takes a lot of energy to pulverize aggregate and concrete to the point that it's dust. And that's a lot of what was there. The other thing, I didn't see any fireproofing on the steel in the rubble, which I find to be interesting. I don't know why that would have been the case, unless there was enough, I don't know. It just doesn't make sense under normal conditions that the fireproofing would have been stripped off of the steel. So.
Where are you getting your pulverized concrete?
By looking at the pictures. Yeah. Yeah.
Were
Yeah.
there casualties?
No. Not for this building. They vacated it a couple hours earlier before it ever happened. Yes?
You know the equivalent earthquake magnitude that was caused by the...
What?
The equivalent earthquake magnitude that was caused by the collapse of the World Trade Centers?
No, we are going to look at that. I have been asked to look at that, and I intend to. I have not done it yet. So what we will do is try to get a understanding of the blast, and then come up with an equivalent earthquake from that to get the same kind of response. Yeah.
At approximately what time did the fires start?
I want to say somewhere early morning.
So they burned all day long then? 'Cause it's
Basically, yes. They burned almost 7 hours, but that doesn't mean they burned in the same place. So everything I've read said they lasted no more than about 20 minutes at a place. So that you got to have to also ask yourself this. The floor 13, I believe it was the one they said it was the place where there was the problem and all that major heat. I'm pretty sure that was a financial tenant that was in there. And the financial tenant would normally not have your records scattered all over the place. They would probably be in safes and files for your protection, because that's their business. In other words, financial records such as stocks and bonds and records like that. So how much combustible was really on that floor? Is really where I'm going with that question. Well, I don't know. It's just hard to say at this point. There would be carpet, there would be, a few other things, but would it have caused, I mean, this is a steel building. How much, where's the burn going to be coming from? Carpets and draperies and papers, but if that's financial, maybe the papers aren't scattered. Maybe they're in vaults and fire-safe things. Yes?
I've actually seen a couple of demolitions of buildings more than 13, 14 stories high. And I've noticed that unless the charges are set right, when the building starts collapsing, when it hits the floors below, there's resistance. There's a pause before the next layer comes down. That didn't seem to be the case in this.
No. If you were to plot that, you will not see a jump. You will not see a irregularity. It was a smooth curve, which leads me to believe that the substation was gone before it ever started. How it controlled the straight down is another issue. So I'm working pretty hard to evaluate if that was a possibility. Yes.
Have the properties of the concrete been tested, like strength tested and height?
I believe so. Getting that information is a challenge. I have requested it. I've requested that as well as all of the inspection reports for everything out there. And so we're working on it.